Have you ever just, looked down at your lunch and really wondered what it's made of? I don't mean just the ingredients, but what's really deep down inside? Well, today we're going to go on this incredible journey, peeling back the layers of reality, starting with your dinner plate and going all the way down to the fundamental particles of the universe itself. Okay, so let's just dive right in. Let's take something super simple, like a piece of bread. I mean, on the surface, it's just bread, right? Baked dough. But if we could zoom in, and I mean really zoom in, we'd find out it's actually a doorway to a hidden subatomic world. So what's really going on inside this humble slice? So on the biggest scale, our food is basically fuel. It's made of these three main things we call macronutrients: carbohydrates, proteins, and fats. They all give us energy, what we call calories, but here's the thing, not all fuel is created equal. As you can see, fats pack more than double the punch of carbs or proteins. They are by far the most energy-dense fuel our body can get its hands on. All right, so let's do our first big zoom in. Our piece of bread is mostly carbohydrates, and specifically a complex one called starch. And this is where things start to get really interesting on a molecular level.
Now, starch is what we call a polysaccharide. That name sounds super complicated, but the idea behind it is actually pretty simple. Poly just means many, and saccharide is a fancy word for sugar. So a polysaccharide is just a really, really long, sometimes gigantic, chain of smaller sugar units all linked together. That's it.
And these starch chains, they mostly come in two flavors. You've got these simple, straight chains called amylose, and then you have these super complex branched out chains called amylopectin. But what's absolutely incredible is that even though they look so different, they're both built from the exact same single repeating building block. And that single building block, the one that makes up all this complexity, it's glucose. This simple little sugar is the monomer that builds the massive starch polymer. And, even more importantly, it's the primary fuel molecule that your cells are just dying to get a hold of to power, well, everything. So we've got these huge tangled chains of starch. How does our body actually get to that valuable glucose locked inside? Well, it calls in the experts, its own deconstruction crew, your digestive system. And its job is to just systematically tear these chains apart.
Think of digestion like a chemical road trip, and this here is our map. It starts right up here in the mouth, and it continues all the way down through the stomach and into the small intestine. And every single stop along the way has one goal: chop up those big food molecules into pieces small enough for our cells to finally absorb and use. Honestly, it's like a super efficient disassembly line. It kicks off in your mouth, where chewing and enzymes like amylase start snipping away at those starches. Then the stomach's acid gets to work on the proteins. And finally, the whole thing winds up in the small intestine, where a whole team of specialized enzymes just finishes the job, breaking everything down to its core components.
And this is the key takeaway, right? After that whole journey, all the complex stuff from your food, the carbs, the proteins, the fats, they're all chopped down into their simplest forms. Starches become glucose, proteins become amino acids, and fats become fatty acids and glycerol. Now finally, they're small enough to get into your bloodstream. All right, so our building blocks are in the bloodstream, heading for every single cell in your body. And that means it's time for our next big zoom in. We're going from the digestive system into the microscopic world of a single cell to see how these little molecules are turned into pure power. Which brings us to the big question. We've got glucose, we've got amino acids and fatty acids. They're inside our cells. So how does a cell turn these raw materials into the energy that literally keeps us alive? The answer comes down to one absolutely essential molecule: ATP, or adenosine triphosphate. You can literally think of it as the cell's money. It's the energy currency. Just like you use cash or credit card to pay for things, your cells use ATP to pay for basically every single thing they do, from making a muscle move to firing a thought. And here is where the cell is just brilliant. It doesn't really matter what you ate. Whether the fuel is glucose from carbs, amino acids from protein, or fatty acids from fat, look at this. All three paths eventually merge. They all get funneled into the same central power plants, like the Krebs cycle, to generate that one precious currency, ATP. And the payoff for all this work? It's incredible. From just one single molecule of glucose, your cells can churn out somewhere between 30 and 38 molecules of ATP. I mean, think about that return on investment. It's like a tiny, controlled energy explosion happening inside your cells, billions of times a second. And yeah, other molecules can definitely be used for fuel. But glucose? Glucose is king. It's the star of the show. As the folks over at Crash Course put it so well, it's the be-all, end-all molecular fuel that your cells need to make ATP. The whole system is basically optimized for it. Okay, so we've followed the trail from bread to starch to glucose to pure energy. But we're not done. We can go even deeper. What is a molecule of glucose itself made of? For that, we need to zoom in one more time. From the world of molecules down to the very atoms that build them. You know, it's actually hard to wrap your head around this, but the insane complexity of our food, and our bodies for that matter, is built from just a tiny handful of atomic ingredients. 4 elements do almost all the work. You've got carbon, the absolute MVP, the backbone of life; hydrogen, the most common atom in the whole universe; oxygen, which is key for all those energy reactions; and nitrogen, a non-negotiable ingredient for every single protein we make. Just look at this. It's a perfect example. This is an amino acid, the building block of protein, and you can see them all right there. A central carbon atom bonded to hydrogen, oxygen, and nitrogen. It's just a few simple atoms arranged in this very specific way to create one of the most vital molecules for life. It's amazing. All right, here we go. We're almost at the bottom of the rabbit hole. We've gone from plate to molecule to atom, but what's inside the atom? Let's get ready for the final and most fundamental zoom of our whole journey. So you probably remember this from school, right? An atom is the basic unit of any element. It's got that dense nucleus in the middle, made of positive protons and neutral neutrons, and it's surrounded by these tiny negative electrons. For a long, long time, scientists thought that was it, that these were the fundamental, indivisible pieces of the universe. Turns out, they were wrong. And this is it. This is our final destination, the bedrock of reality. A proton, something we all learned was a fundamental particle, isn't. It's a composite particle. It's actually a tiny bundle of even smaller, more elementary particles, and they are called quarks. This is the truth at the bottom of it all. Everything we've talked about, the bread, the starch, the glucose, you, me, it's all ultimately just an arrangement of quarks. And get this, all the stable matter in our universe, everything we can see and touch, is built from just 2 flavors of these quarks, the up quark and the down quark. And they have one of the most bizarre and frankly wonderful properties in all of physics. They have fractional electric charges. An up quark has a charge of positive 2/3, and a down quark has a charge of negative 1/3. It's like cosmic Legos. You combine 2 up quarks and 1 down quark. You get plus 2/3 minus 1/3, which equals a total charge of +1, a proton. You combine 1 up and 2 downs, and you get a charge of 0, a neutron. All the matter you eat is built from these strange fractional pieces. So, we made it. From a bite of bread all the way down to the quarks vibrating inside its protons, the incredibly complex world of food, digestion, and energy is, when you get right down to it, just a magnificent rearrangement of a few tiny fundamental particles. So it leaves you with one last thought. What does your next meal look like to you now?